Welcome. We're so excited to present to you advances and updates in Merkel cell carcinoma. Let's see here. Get this to behave. Here we go. Okay. And do the right click thing here. Get the pointer to behaving. Laser arrow. Thank you. There we go. Okay. Yes, Mac, keep me on board. Thank you. Okay. So I'm pleased to give you some introductions tonight and some project highlights of what's been going on. Then Mac Cook will talk about how donated tissue helps research. Mac is well positioned to do that because he's a research scientist who gets those pieces of tissue and processes them. And then Kelly Paulson will round out our evening by telling us a lot of exciting progress that's going on in terms of improving immune therapy for Merkel cell carcinoma. In order to take really good care of patients, and that is as simple as it sounds, the main goal. Patients are first. And we use that phrase a lot to decide how do we balance all these things. What we really need is a wonderful extended team that can have the expertise necessary to manage really tricky cases and communicate very well. So the village that we have put together to take care of Merkel cell carcinoma patients, I believe, is the best in the world. And it involves this team of medical oncologists, dermatologists, dermatopathologists, radiation oncologists, nuclear medicine doctors, ophthalmology, radiology, and a team of surgeons. And those people have to talk often and communicate well. And that's something that we work very hard on to maximize and improve the best care that we can give. That Merkel team clinically is supported by a wonderful nursing team, a clinical research team, including a phase 1 group that focuses on drugs that are earlier on in their development, patient care coordinators who have a super important role in the first phone call, picking up the phone for the first time when a patient calls with a major problem and getting that person's data and getting them all scheduled with the right doctors. These folks do a wonderful job, and then our biostatistics, bioinformatics team help take all that data that we're getting from all those sources and tell us what, how to best make that work. Hi, Mom. Okay. We have two exciting additions to the Merkel team, and one is Dr. Kelly Paulson, and at a certain level, she's been a very close part of our team for over a decade as my first trainee here in Seattle, doing her MD PhD program here and publishing over 30 papers on Merkel cell carcinoma. But as of a few weeks ago, she's officially an attending doctor in medical oncology. Bravo, Dr. Paulson. Yay. Yay. Even for Kelly, who does things about 5 times faster than a normal human, it takes a little while. And then Coley Doolittle Amieva is our wonderful new physician assistant specializing in skin cancer and Merkel care in particular. She practices medicine with attending oversight and just has made our whole team function much, much better. And it's just wonderful to have Coley on our team. Here is our skin cancer research team based here at University of Washington in South Lake Union. We have clinical research fellows, medical students, and physicians, as well as research fellows, undergraduate research assistants, research scientists, and Dr. Kawasumi leads a lab that focuses on basic DNA damage. You heard them talking a bit about caffeine and preventing DNA damage and learning better ways to treat cancer. We have wonderful collaborators on Merkel cell carcinoma projects. Many of the folks, all of the folks in this top line are focused on T cells, which we'll be talking about a lot tonight as the most important part of the immune system for fighting cancer. And these T cells are the ones that recognize and kill the cancer cells, and then the whole rest of the immune system is there to support them. And the B cells and the antibodies, though, that float around in the blood, Denise Galloway, who's in the back there, had worked with Kelly Paulson and others to develop this test almost, immediately after the virus was discovered. that we now use, and Kelly's going to be talking about that and the impact that that has made, and this team that has focused on that over the years. We have several of our teammates from radiation oncology here who are helping us make conceptual improvements in how we're going to somehow someday use radiation even better to turn on the immune response. And these folks in pathology help us analyze the tissues and look for the virus. We have a lot of core facilities, which are certainly something that you guys wouldn't think about normally, and most of us don't think about that often. But these are the people who are sponsored by the Hutch and by UW and by the NIH to help do expert things like process tissues, process blood. Thousands of samples get frozen and processed, and Mac Cook is going to talk about how you stick the tumor tissue into formalin, and then you can study it for decades after that in great detail. This team is our PDX, or patient-derived xenograft team, and that has very excitingly allowed us to grow patient-specific tumors with great reliability from even a tiny piece of tumor the size of a piece of rice, a grain of rice, can grow in a mouse that's not got an immune system, and then we can study that tumor sort of indefinitely. These folks are involved in our clinical trials. Lisa Lundgren is here tonight, and Osa is here, and others. And this trial is what we were talking about in terms of Keytruda and pembrolizumab, led by the CIT and the Cancer Immunotherapy Trials Network. We believe this is going to lead to the first approval for that drug in Merkel cell carcinoma later this year. Our UW Dermatology Academic Office keeps all of our operations going and hiring people and promoting them and making sure they get paid and taken care of. Our UW Advancement team with Christine and Elena help us work with philanthropy and raise money, which is very important in keeping our efforts going. And as I've mentioned, our industry partners are incredibly important in translating and making an impact in this cancer. And here are some of them, and many of them are here tonight, and we are super appreciative of the impact they're making. We could not do it without them. So we have a great Merkel cell carcinoma team. I'd like to now give you a tiny bit of information about how that team is having an impact. And one of the scientific ways to measure impact is how many papers are published and how many times those papers make a difference. So we've had 82 papers on Merkel cell carcinoma published since 2003, talking about the disease in general and better ways to treat it and why people do well or do poorly. And just in this past year or so, 2017, 2018, we're at 23 thus far. And the impact of those papers can be measured by how many times they're cited, which means how many times somebody else's paper says, oh, that study was important. And that number, as you can see, has been going up very, very nicely in terms of the number of citations of these papers to over 1,000 per year, and we think and hope that will continue. In order to maintain such productivity, of course, funding is needed. And our major funding sources have been National Cancer Institute, National Institutes of Health, the American Cancer Society with over $8 million in grants since 2006. And one of the biggest things that we have put together is a program project grant involving about 30 people or more, 750 pages. You heard about this last year. We had submitted it, and it got a very good score or evaluation review, but not quite good enough. And so we've improved a lot of aspects of that and done a bunch more experiments, addressed the things that the reviewers wanted to have addressed. And so we're crossing our fingers that in 2 weeks, when we get our evaluation this time, that will go well. Even if we get this award, though, and especially if we don't, we rely very heavily on donors, many of you. We have received over 3,700 donations since 2006, with typical being around $75 and totaling a very impactful $3.6 million from lots of sources, including some of the folks that are pictured here. These monies are super important because they don't have to be spent on a particular schedule. They can be used for something that we see coming up rapidly and that's important, and they don't have to be, we can just do what we need to do with them, and they fill the gaps when the other funding goes away. So I'm going to shift now to 2 slides, background on Merkel cell carcinoma. Friedrich Merkel is pictured here in 1875. He drew pictures of rat paws where there's a high density, that's like the little furry rat with the tail, and their paws have a very high density of these cells that he called touch cells, and they're pictured here connected to nerves, and they look almost exactly like the cells in Merkel cell carcinoma. We now believe that Merkel cell carcinoma does not come from normal Merkel cells or touch cells, but that there's sort of a convergence of the way the cells look. But these things are purple and red, hence the colors that you see out there. That's kind of the colors that we chose for the ribbon, because those are the typical colors of a Merkel cell carcinoma. And Kelly Paulson has now just published the incidence of Merkel cell carcinoma has hit 2,500 cases now per year and is going up quite a bit faster than actually any other type of cancer, and we believe that that's because of the strong relationship to the immune system. And as we get over age 50 and 60, just like we get reactivation of the chickenpox virus with shingles, we believe that the immune system isn't as strong and that the cancer can hide from it. And so the rate of Merkel is going up, and these are reflected here by the number of baby boomers getting over the age of 50 and 60 and such. These are the risk factors: advancing age, sun, Merkel virus, and immune suppression. But it is important to note that over 90% of patients with Merkel cell carcinoma do not have anything that we are aware of that's wrong with their immune system. Besides perhaps being over the age of 50, which does make our T cells not work quite as well. So there are 2 causes for Merkel cell carcinoma. One is the virus and one is sunlight. The virus leads to about 80% of cases and sunlight leads to about 20. And these are both interesting conceptually, but also important in terms of therapy. The virus, we know, discovered only in 2008, is insanely common. We walk around with a Q-tip on most of our foreheads tonight, and we will find a tiny amount of Merkel cell polyoma virus. It does not cause any problem that anybody in the world is aware of, except in 1 in 3,000 people over their lifetime. It will lead to Merkel cell carcinoma by having these very, very rare mutations happen. The virus integrates into one of our chromosomes. It doesn't normally like to do that, and then it has to be chopped in a couple other places. If it isn't chopped and it just integrates, the cell just dies right away. So weird, multiple things have to happen, and probably based on bad luck, and then pieces of the virus are made and cause the cell to grow. Those pieces of the virus are really visible to the immune system. Very important. In contrast, for people who just get this from sunlight, we know there's no virus there. That's been very carefully shown, and they need lots of mutations, more mutations than it takes to get squamous cell carcinoma or melanoma or something like that. Hence, Merkel is more rare. More things have to happen, and when those mutations happen, they change the normal proteins in the cell and make them look abnormal and thus visible to the immune system. So you can see where I'm going here. Both virus-positive Merkel and sunlight-induced Merkel are altered compared to the normal cells in our body, one because of a virus and one because of a whole bunch of mutations caused by sunlight, and the immune system should be able to see that in both cases. Merkel should be very visible to the immune system, in particular the T cells. This is something we've been studying for basically a decade now, lots of data pushed in that direction, and we were very excited to test whether immune therapy would work. So I want to show you now, this is very hard. We spent a long time trying to not be wrong in what we say, but also not be insanely complicated. So we're going to show you the key issue here, where a T cell that is recognizing the cancer, those unique aspects of Merkel cell carcinoma, whether it be the virus ones or the sunlight-induced ones, how they communicate with the cancer in this case. And there's a pathway that's become increasingly understood called the PD-1, PD-L1 pathway that interacts and the cancer uses as a tool to shut off the immune system's ability to kill it. So it interacts with this PD-1, PD-L1 binding, And that binding shuts down the immune system, either kills the T cell that would have controlled the cancer or makes it not function as well and not be present as much. So over the past years, many people, certainly independent of us, came up with ideas to block this PD-1, PD-L1 pathway. And that can bind either PD-1 or PD-L1. These are the drugs that you're familiar with, Keytruda, Opdivo, or Bavencio, or the longer, fancier names here. A couple of them bind on this side, one of them binds on this side. We don't think that's very important. What happens that matters is that there's something blocking. And this little blocker comes in there and stops the cancer from being able to shut off the immune system. So the immune system and those specific T cells are then able to go and damage and kill the cancer. That's the concept. That's been a concept for quite a while. Does it work? We now know it works. Here is a graph that I will explain to you that shows that immunotherapy improves survival for advanced Merkel cell carcinoma. This is the number of months, up to 36 months, after a patient has developed advanced metastatic Merkel cell carcinoma and started a IV treatment for it. The old days, the only option was chemotherapy, old days being 2 years ago. 100% of patients on the day they start their immune therapy or they start their systemic therapy are fine at the beginning. They're alive. By 6 months, that's down to 70%. By 12 months, it's 45%. By 36 months, it's about 10%. That's how well chemo worked. These are two separate studies of chemotherapy in Merkel cell carcinoma showing very similar effects. Here's how pembrolizumab, one of those drugs, and we believe now all three of those drugs that have been tested in Merkel cell carcinoma work very similarly. Here's how that works. So that takes you from 10% to 60% at this time point, being alive. That's not a very complicated thing. It's, are you alive? Are you dead? And this is a very big difference. It's not just, do you have disease or not? Some of these people do have disease, but fully half of them are doing great. Their disease is controlled in an ongoing way. We now believe that this, based on that announcement last week from the FDA and Merck, this drug is going to have a decision made about it in December, and we fully believe that these data are going to mean that decision is yes. And this study was developed here, and we were laughed at by many people for saying this should be done, especially that it should be done before chemotherapy. Most people said, you got to give chemo first because chemo works. We said chemo suppresses the immune system. So trade-offs. But in the end, now this worked, and everybody thinks immune therapy should go first. So what does that mean? The National Comprehensive Cancer Network is the organization in the United States that's an aggregate of 20 cancer centers across the country that determines how to treat a given cancer and what gets reimbursed, because the insurance companies respect what this group decides. Up to 2016, for metastatic advanced Merkel cell carcinoma, there was only one option, chemotherapy. Nothing else is listed. In 2017, two things happened. Number one, they listed prefer getting on a clinical trial. And pembrolizumab made it at the very bottom of the list based on our study. And in 2018, the world just flipped. Clinical trial is still preferred. 3 drugs, avelumab approved, Bavencio, and pembrolizumab and nivolumab. With those drugs are approved for other kinds of disease, other kinds of cancer, and there is public data showing they work really well. So those got listed, and that means insurance companies would pay for those drugs. And then this is a key sentence. As clinical judgment dictates, for patients with contraindications to checkpoint immunotherapy, then chemotherapy. Only if you can't get immune therapy. So some of us were, talking about how we got mocked for saying, no, you should give immune therapy instead of chemo, and those were hard days, and we're so glad we're past them. So immunotherapy is now standard for metastatic Merkel cell carcinoma. Is it useful in preventing recurrences? That's a question we're getting all the time from our patients, because we have patients here with high-risk Merkel cell carcinoma who have been treated with surgery or radiation and have no evidence of their cancer left that we can find by scans or anything on exam. And depending on how much they had, like nodal disease with an unknown primary or nodal disease with a known primary, they have something like a 70% chance. Even though we can't find any cancer, they have a 70% chance that the cancer will come back by basically 2 years. You can imagine what they're saying to us in clinic now. What do you mean you got these great drugs and I can't have them? Well, it's not so straightforward as to whether we should be giving patients those kinds of drugs without any evidence of cancer. So Dr. Bhatia, Shailendra Bhatia, has developed an exciting new trial that is underway now called the ADAM trial, or Adjuvant Avelumab in Merkel Cell Carcinoma, where adjuvant is a complicated word. It means a patient who no longer has evidence of cancer that we can detect, but is at high risk for having it come back, and giving them a drug in order to prevent that cancer from coming back. So we're going to take 100 patients with high-risk Merkel cell carcinoma after they've had their surgery and their radiation and we can't find any cancer in them, and then we're going to split them into 2 groups by random. Those that will get standard of care, which is basically placebo, and they won't know whether they're getting placebo or avelumab, or they will get avelumab. We believe this is ethical because some of those people will get avelumab and won't need it, and avelumab is both expensive and has potential significant side effects, and we also don't know how well it's going to work in this setting in which patients have no evidence of disease. So we're very excited this trial is going forward. It's going to answer the question well, and here are the sites around the country in green that have it open, and the red ones are going to have it open soon. So that's the end of what I'm going to say, and we now have 2 folks who are going to tell us a little bit about their experience. If you guys want to come down, Dan, with their journey in Merkel cell carcinoma and how it's been. Okay.
Well, it's good now, but it wasn't for a while. Good evening. I'm Dan Shea, and I'm honored and I won't say excited. I'm honored to be here in front of you and tell you about my experiences and history with Merkel cell. I first came upon Merkel cell in 2013. I had a growth on the inside of my knee, and I thought it was an ingrown hair, but it kept getting bigger, and then pretty soon it looked exactly like the inside of that person's knee on the screen there. Just a big red thing that looked like a cherry tomato cut in half. So I went to my dermatologist. I thought it was a cyst, and he looked at it, and he thought it was a cyst, and so he cut it off. And so we thought we had it. So we thought I was good to go, and about a month later, just before Christmas, we got a phone call that said, hey, it's this wild, crazy thing called Merkel cell carcinoma that we'd never, ever heard of. So he said, we're going to make arrangements for you to go see the doctors in Seattle. We live in Port Angeles. And he said, don't go and Google this thing, please. It'll just scare you to death. So as soon as he hung up, we did. We ran and we looked at it. And it said basically what doctor just said a little while ago. I had 3 to 5 years to live. And so, that's the way we came to Seattle. So I remember that first day at Seattle Cancer, excuse me, Seattle Cancer Care, standing right in front of those great big windows. I think we probably all stood there before looking out at Lake Union and thinking, how can this be happening and what's going to happen next? And then, we got herded into the room with Dr. Niemann and his great team where there wasn't even any place to even hardly stand in the room. And all these, he used the word great team. I mean, that came to my mind right away because here was all these caring, wonderful people that, took 4 of us that were there and changed our attitude and our outlook on life and gave us a plan and a way to go. So the first step then was, the dermatologist had done his job. He had taken it off, but he didn't quite get enough margins. So, we did Dr. Bird, one of the team. He did exploratory surgery at the UW and took out my the first lymph node. I can't remember what you call it. He took that first one out, and sure enough, it had some of the cancer there. So he took it out, and then from then on, radiation was the thing they talked about next. Doctor said he didn't want to do chemotherapy, that we do radiation. So, the subject came up of doing it in Seattle, which, I didn't really want to do it because we live in Port Angeles, and 5 weeks of radiation would have meant traveling to Seattle every day to do it, which would be basically a minimum of 6 hours driving back and forth, or moving to Seattle for 5 weeks, and then taking 5 weeks of sick leave from work. And so Dr. Neem did a little research and found out that 20 miles down the road from us at Squim, they have a cancer care unit there, and they have the equipment and they have the personnel that could do it. And so I was able to get my radiation there, 20 miles away, which, was just like a big sigh because we didn't have to do the trip to Seattle thing all the time. And they were so great at Squim, they would get me in at 7 o'clock in the morning, I'd do my radiation, and I'd actually be to work at 8 o'clock in the morning. So, it worked out perfect. So things went well for the next 3 years. I did have a little hiccup in the spring of 2013. I was diagnosed with prostate cancer, so I had to have my prostate taken out, and then 5 more weeks at Squim. So with my buddies down there, getting the radiation there. But again, they worked me in. I was able to get the radiation, but that had nothing to do with the Merkel cell. Then in the fall of that year, I had another bump on my leg. So I thought, shoot, I'll bet that's it again. I could just tell it was. And before long, it wasn't on the inside of my leg, it was on my thigh. But I met with Dr. Neem, and he said, yeah, it's back. And so we did surgery at the UW, and then 5 weeks of radiation and Squim again. And I was good to go. So excuse me, I really felt like we had it then, because it had gone 3 years. It came back, but I just, listening to the doctor, he just, and the great team, they made me feel like it was gone. But it didn't last very long this time. In 2017, it came back again. And so I noticed a couple, I have to do lymphedema exercises because of they took that lymph node out. So every day I do them, it keeps the swelling down in my leg a lot. And I was doing the lymphedema exercises one day, and I felt a couple bumps there. And so then within a week, I probably had 4 bumps. And I had made an appointment in the meantime. But by the time I could even get over to Seattle in the week or 2 that it took to, for the appointment to come, I had 8 bumps on my leg. So met with a doctor, and he says, well, radiation isn't working, and surgery didn't work, so let's try something new. So they explained infusions to me, and it sounded exciting, and all of a sudden, all this depression kind of went away from us all, and we met with, he took us down the hall, and we met with Dr. Badia, and he explained the infusion program, and so we made a plan, and the plan A was Keytruda. And, everybody was talking about all the exciting things that were happening with Keytruda. And plan B was to do the clinical trial of the drug the year before that was doing real well too, but they really thought Keytruda was a step up. So long story short, my insurance company would not approve Keytruda. So we decided we'd go to plan B because we needed to get moving on this thing. And just right then, Merck stepped up, and they contacted us and said, hey, we'll supply the Keytruda at no cost to you. So we thought, whoa, what a cool deal. And so we were excited. I had my first infusion in Seattle. Dr. Badia thought that we needed to do these infusions in Seattle because it's an expensive drug. Squim has the cancer unit there, but he wasn't exactly comfortable with the oncologist that they had there. And so he said that we needed to do it in Seattle, and I understood that because it is an expensive drug, and Merck was being good enough to supply it for us. So So I had my first infusion, and then it was time for my yearly trip to my hunting trip to Montana. That I didn't want to give up. I thought maybe the doctor was going to make me give it up, but he said, no, we can go, and they'd adjust my schedule a little bit. And so off we went to Montana. And so after a weekend being in the mountains, coming back the night before we were going to leave, everybody was at the motel, and we all went in to take showers, and I was in taking a shower, and I went to wash my leg. Every one of the bumps was gone in 1 week. I couldn't believe it. So and there was not even a trace of them. So I mean, it's kind of a scene there, because I went screaming out of the bathroom in my underwear. All my buddies we're all hooting and hollering and toasting the Keytruda. So, and then another little funny part. I swore him to secrecy. I said, now don't you tell anybody, because I want to tell Wendy myself when I get home. So I got home, I ran in the door, and I unbuttoned my pants, threw my pants down. She starts screaming and says, go back to Montana. So anyway, it must have been quite a sight, because then she realized what I was trying to show her. And my leg. Anyway, it must have been quite a picture of the two of us sitting there crying, and me with my pants down around my ankles. Sorry.
Dancing. I don't know what's doing.
It's probably me hitting it. Sorry. Yeah. So every 3 weeks I would go to Seattle, and that was the nice thing about Keytruda too, because it was a 3-week program instead of a 2-week program. And so then I didn't have to go quite as often to Seattle, and work was really good, and I could, if I had an early appointment, I could leave early. We leave 4 o'clock in the morning. That way we didn't have to worry about the Hood Canal Bridge or missing a ferry or something, and we could be here early, and I could be basically back to work by 1 o'clock in the afternoon. If it was an afternoon thing, then, excuse me.
No, that's okay. No, I was just going to say, how long ago was Montana now?
How long ago?
Yeah, how long ago did you have that wonderful response?
That wonderful response was last October.
Last October, so a year.
So I better shut up now, because I'm talking too long. Okay, but let me just tell you one thing before and I'll skip the rest of it. I've had 14 infusions, and now the last 5 I get to have in Seattle area in Squim, because Dr. Badia likes the oncologist that's there now. So I don't have to go to Seattle. It is, it's such a great thing for our lives, because we don't have to be doing that trip to Seattle. I'm not really fond of coming over here, and no offense to Seattle, but we're small town people. I feel great. My PET scan a month ago showed no cancer at all. I got 2 more infusions to go with the Keytruda, and then we're going to quit. Okay, and see what happens then. But I have total confidence that I think we've got it. Okay, so. Can I say thank you one real quick?
Quickie. Yeah.
So really fast, I want to thank Wendy, because I couldn't have done it without my wife and my kids. I absolutely couldn't have done it. Dr. Neum and his team, Dr. Badia, the people at Squim that were so good to me, my family, family and friends that prayed for me all the time, and to Merck. Thank you, Merck. And to quote my grandmother, God love him.
Well, on Friday, September 1st, 2017, I sat at my desk after I'd sent everybody home early for the Labor Day holiday. I looked down at my ankle and I said, wow, what's the swelling from? I think something's going on there. My name's Steve Murphy. I live in Frisco, Texas, and I work in Oklahoma City, Oklahoma. I went to the doctor that afternoon. They immediately looked at me and said that I needed a CT scan, and my life turned 180 degrees. Okay. They didn't know what it was, but they told me it was very serious, and they would only release me if I promised to see a doctor the next day. Well, It took about a month of tests in the DFW area before I got a call from the doctor that says, we're not really sure, but through a process of elimination, we believe you have Merkel cell carcinoma. I'd never heard of Merkel cell. It was a disease I wasn't familiar with. I'd never even heard the term. So at that point in time, I was somewhere between denial and shock. And during that period, my wife, Susan, started to do search. And it was very interesting because everything that she searched for, two names kept coming up, Dr. Nim and Dr. Bhatia, okay? So their names just kept coming up. And so at that point, Susan, being assertive, called SCCA and said, have I got a patient for you guys, right? And it was just wonderful. From the time we talked to Sylvia, we just felt like, immediately doors started to open. So on October the 10th of last year, I met with Dr. Nim and I met with Dr. Bhatia, along with other physicians from UW. And I was really impressed. They offered me an open slot in a clinical trial. The next day, I signed my IPI-NIVO consent form and began treatment on October 17th. So, Bristol Myers Squibb, I don't know if you're here. I'm your biggest lab rat. I'd love for you to come up and introduce yourself to me, but thank you so much for having that trial available. So people ask me, why UW, why SCCA? Well, I'll give you two main reasons. One was our search pointed us here because of your research and innovation, okay? And secondly, because you provided something to us, my family and I, that nobody else had provided. Maybe nobody else could, and that was hope, okay? So I travel every other Sunday from Oklahoma City to Seattle. I'm treated on Monday, I'm released, and I'm back at work on Tuesday, okay? I have received attention and treatment beyond what I could have even imagined. Truly, the specialists here are available 24/7. I can call about the smallest thing or the most important thing, and I get immediate attention. The efficiency's been remarkable. Dan and I were talking about that. I've never been treated anywhere where I've seen such efficiency and concern about the patient. I want to thank my research coordinators from the first one I've had to the one I have today. I want to thank all the physician assistants and all the researchers. But now I want to just speak briefly to those folks who are not here today who may watch this on video, okay, and may just be beginning their treatment journey. I want to say that UW and SCCA has been the right decision for me, and it may be the right decision for you. I stand here today because of the hard work and dedication of the people in this room. I wish I could take, and just do a group hug with all the folks that I saw in the picture there. I can't do that, but I will say humbly, I offer you thank you for what you've given me. You've given me my life back.
That's hard to top. Thank you very much, both of you. Mac, you want to come up? So Mac's going to now tell us, we've focused on progress. We've focused on some happy stories. Half of our stories aren't ending so happily. We need to do more, and Mac is going to tell us what the role that he has that's very important in helping us learn more.
Thank you. Thank you for the introduction. All right, so from my talk, my main goals for you to have after listening to me speak tonight is what goes on behind the scenes of when you're donating your research biopsy tissue to our lab, and also the important advancements that biopsy tissue has made for us. So looking up here, these are some relevant locations for where these biopsies may or may not be collected. So up here at the top, we have the UW Medical Center, of course, where you might be having a surgery or an ultrasound-guided biopsy. And then that's where we'd be picking up biopsy tissue for those purposes. And then, of course, down here we have Seattle Cancer Care Alliance, where you may be even seeing Dr. Niem or Dr. Bhatia in the clinic to get yourself a punch biopsy, and that's where we'd be picking up those samples. And then I'm usually the one, or my coworker Rima are usually the one to pick up these biopsies, and we'll take them from either UW Medical Center or Seattle Cancer Care Alliance and shuttle them on down to UW Medical Center, South Lake Union, where we are currently located. And so that's just to give you a rough schematic of where we're doing our work. So usually we typically start off, we have the patient here, and so we'll get a tumor biopsy. And the really interesting thing here is we can get anything ranging from the size of a grain of rice all the way up to a grape. And these biopsies are usually pretty safely obtainable. And typically we'll take these biopsies and we'll do one of two things with them. Up here at the top, we have this culture media. I like to think of it as like a cell Gatorade that'll keep the tissue and cells nice and alive and happy. And then at the bottom here, we have formalin. And so this formalin will actually pickle the tissue, quote unquote, and preserve the interactions taking place in that tissue for decades to come. And so I'll start off by talking about what we do with this formalin tissue. So here, how we use this pickled tissue, we do different sorts of staining techniques with this tissue. And so by that, I mean we use fluorescently labeled molecules used to identify specific cell features. And so here we have these T cells, which Dr. Nia mentioned earlier, that these are the immune cells that your body produces that will help fight the cancer. And then we have, of course, the cancer cell. And so notice that each of these has unique markers on it. So I labeled them on this slide as C, D, A, and B. And so that is how, those are the markers that will help your body identify or differentiate between these cells. And so we can then add molecules, such as this one here, floating onto cell marker B. And so this is what we call an antibody. And this is a molecule that's going to bind to the outside of these specific cell characteristics, and it has a fluorescent label attached to it. And that fluorescent label is actually what we are able to see using a microscope. And so then we have another molecule that's going to go ahead and bind to that T cell. And so now you're thinking, okay, well, that's interesting. Well, like, what can we get from that? So here's what's happening actually inside the tumor during or after one of these staining procedures has taken place. And so this image right here is actually from a tumor biopsy, magnified hundreds of times. And so we have all this purple is actually stained for Merkel cell carcinoma tumor. And then these green little dots are T cells. And so there are hundreds of little Merkel cell carcinoma cells present in this area, and then a few T cells in the outside or peripheral tumor environment. And so one of the things to notice here is that there are no T cells actually present within that tumor tissue. And so this was a patient that this was a biopsy taken from a patient before they received T cell and immunotherapy treatment. And so we then got a later biopsy on that same patient after their tumors began to shrink. And so one of the big things you'll notice here is that we have a lot of these little green guys or T cells present within that Merkel cell carcinoma tumor environment. And so that was a very interesting finding to us because we found out that, the T cells can't just be present around the tumor, they actually need to be infiltrating or entering that tumor environment to have an effect. And so then again, from that same patient, after their cancer started recurring or coming back, we found, again, from this biopsy that the T cells were no longer present in that actual MCC tumor, and they had moved then to the outside. And so what this is really showing us is that we need biopsies at critical times to understand why these therapies are not working. And so one of the last things you might want to be focusing on after your cancer is coming back is donating research tissue. But it's at those critical time points that really help us understand what's happening in this complex disease. And so shifting gears back to the tissue that we might place in a cell media or cell Gatorade that keeps the tissue alive is what we do with the processing there. And so typically I'll take this tumor and I'll dice it up or mince it. Really, we're just trying to increase the surface area to volume ratio on that tumor and have it ready for the next applications. And so one of the things we'll do on the same day is actually add this little dissected or minced up tumor to a chemical mixture that'll turn it into single cells. And so here we have a little zoomed in view of all these little single cells that might be present in that tissue. And this is comprised of blood cells, and this can be anything ranging from white blood cells to red blood cells, so your immune cells, and then, of course, tumor cells. And this is really interesting because it allows deep analysis of thousands of these single cells. And, this can come from a sample, again, even as small as a grain of rice. And Dr. Kelly Paulson is actually going to go a little bit more in depth about this during her presentation. And so a second thing we'll do with these fresh tissue biopsies in the cell media is we'll do what's called a T cell culture. And so really that's just we're adding this diced up, minced up tumor to some special cell media that will specifically grow out these T cells, and we'll end up with a population at the end of 2 weeks of basically only helper and killer T cells. And these are the T cells that we really want to focus on, because these are some of the immune cells that help fight the cancer. And so focusing on these T cell cultures, the things we want to do with these T cell cultures is search for virus-specific T cells. And so if you remember earlier, Dr. Nia mentioned that 80% of these Merkel cell carcinoma cancers are caused by the Merkel cell polyomavirus. And so that's something that your immune system can go on to recognize, and that's actually presented on the outside of these cancer cells. And so we want to study the T cells that actually can find and locate these cancer cells presenting that virus. And so if you direct your attention down to this little cartoon I have here, we have a cancer cell presenting the virus and the killer T cell with a receptor that is specific to that MCC virus. And so the killer T cell will go on to bind the cancer cell, and then it will release these cell signaling molecules that we like to call cytokines. And so those cytokines are actually detectable to us and allow us to know that the T cell is then activated and is going to go on to kill the cancer. And so one of the studies we can do with this and kind of study these killer T cells, we use a technique called flow cytometry. And before you get too nervous of looking at this diagram right here, we have, this is a flow cytometry output reading. And so looking at these two graphs here, we have, on the left here, we have a graph that has very little T cell activation. So notice that on these graphs, each little dot represents a single cell. So each graph is representing tens of thousands of cells. And we want to focus on the ones that are ending up in this little area or quadrant of this diagram right here. Because if a cell is in this area, it's telling us that it has released cytokines. So it's been activated by the cancer. And then it's also a killer T cell. And so we see on this graph on the left that there's very little T cells that have been activated there. And then on the right, we have a graph that there was a lot of T cell activation. So all these cells right here are killer T cells that are specific to the Merkel cell carcinoma cancer. And these are the guys that we want to study. And so this has helped us better understand how to optimize T cell therapy, because if a patient's going to be receiving T cells, we only want to be giving them T cells that are going to go on to fight the cancer, not just the plethora of different T cells that are present in your body at any given time. So in summary, I hope you understand that technology is rapidly evolving and is allowing us to become incredibly efficient with these tumor biopsies we are collecting from you patients, and that these donated samples are essential to making further progress in Merkel cell carcinoma research. So with that, I'll direct the mic over to Dr. Kelly Paulson, which is going to be giving you a talk on improving immune therapy and the future directions that's going to take. Thank you.
Hello to all the familiar faces in the crowd. So as you've heard tonight, there's been incredible progress in therapy for Merkel cell cancer. We know that these PD-1 or PD-L1 therapies are life-saving for many. And for over half of the patients that receive these treatments for their metastatic MCC, they will have durable long-term disease shrinkage or even complete regression that lasts for many months or years. With this great joy and progress brought to us by so many that are listed at the bottom here, there has also been another side. We know that for about 20% of patients, these medicines will work and their cancer will shrink, but then a number of months or years later, for reasons that we're working very hard to understand, the cancer will come back. And frustratingly, for over a third of patients, they will receive no benefit from these medicines, despite this being the best available treatments. We're thus pursuing research in many areas to improve immunotherapy. I'm going to list 7 of them here today with hopes that one of them may apply to your current situation, and then I'll focus on 3 to go into in detail. We're very interested, as you've heard, about giving immunotherapy earlier. Can we prevent the cancer from coming back? If you have a high-risk Merkel, we've cut it out. We want to see if we can treat things early. This is the ATOM trial that you've heard about earlier. And if you're potentially interested, I would encourage you to talk to Dr. Bhatia or one of his study team. We're interested in detecting Merkel cell cancer early when it comes back so that we can treat the recurrences when they're smaller, with hopes that this will allow us to better stimulate the immune system to fight it and shrink it and better advantage us to have more T cells compared to tumor. We're really interested in learning who's likely to respond to immunotherapy. We want to give people the right amount of treatment. If your treatment is not likely to work up front, we want to give you a bigger treatment up front. And instead, if we know that your tumor is likely to be controlled by a single medicine, we want to give you a single medicine. So putting the right treatment, applying it to the right patients. We're interested in determining whether we can give immunotherapies with less side effects. Gratefully, we know that serious side effects are rare and only 10 to 15% of our patients treated with the PD-1, PD-L1 patients. But when these side effects happen, they can be serious and in some cases life-threatening. So we're interested in seeing if we can improve on this high bar. We're very interested in understanding when immunotherapy works and then it stops, why? We think we have a good understanding of knowing why the immunotherapy works. We're stimulating T cells. We know that the cancer is immunogenic to T cells. We think we understand what's going on there, but what we don't understand is that often these cancers will come back and the T cells will still be there. What happened and why is that? And understanding this problem, we believe, critical to developing next generation immunotherapies to help us overcome the hurdles. We're interested in understanding what medicines we can combine with immunotherapy to make it more effective or better tolerated. And finally, for those that lack good immune recognition of their Merkel cell cancer, we're very interested if we can use new engineering approaches to teach their immune system and their T cells to see the Merkel cell cancer in order to restore an effective immune response. So the first of the three that I'm going to talk about today is detecting recurrences early with hopes to treat smaller tumors when we're given the drugs. So we have this assay called the Merck assay. You've heard some about it tonight. It's a serology assay that does a Merkel cell virus antibody blood test. And so this is a test that can be done on a small amount in the peripheral blood. Less than a milliliter is needed to run the test. And how it works is it exploits the immune system as the amplifier. So your immune system can see your Merkel cell cancer, and if the Merkel virus is in it, it works like an amplifier and makes these things called antibodies that circulate all throughout the body. And if you can have one Merkel cell, you can make thousands of antibodies in response. So we're able to use this to detect cancer at very low levels. We encourage folks to have their first test right after diagnosis. If the test is negative, we know that this test is not going to be good for following that individual long term, and we also know that they're at much higher risk of their Merkel coming back, about 40% higher. So this person is really going to need scans, like CT scans or the like, to help follow from an imaging perspective to detect Merkel recurrences. And we know that it's somebody that we need to watch really closely. If instead the Merck test comes back positive, we can complement scans with this blood test to help us detect recurrences earlier. How the test works is it's at higher levels when there's more disease. So in the case of this individual, when they were first diagnosed, the test was here. It fell about 5-fold after the cancer was cut out and there was no evidence of disease, and then more than doubled when the cancer was coming back, indicating to us that the cancer was returning. Importantly, this Merck test is not only useful in the pre-immunotherapy era, but can be also used in patients that are getting immunotherapy to help us determine whether the cancer might be coming back in the context of immunotherapy. Of course, if someone has disease advanced enough to be getting a treatment, we recommend CT scans. However, we believe that this test can also be useful in this context as well to help provide additional information. This test has been nationally and now internationally, we're learning from our colleagues in France, adopted, and really only exists because of your research support. In the United States, all Merck assays are run through the University of Washington. Blood gets sent to us from more than 50 cancer centers in over 20 states. And the test has been adopted by NCCN guidelines as of this year. More than 1,000 Merkel cell carcinoma patients have been tested with the Merck assay, many of them many times. And this is a test that has been clinically live for less than 5 years. The test utilization continues to climb and is anticipated to grow further. We're now running over 100 Merck tests every single month. Importantly, although it is often reimbursed by insurance, Merck still, despite this insurance reimbursement, runs at a loss. It's because it's a very specialized assay. We run it here because we're dedicated to getting that information. But this assay is absolutely dependent on MCC gift fund donations, and we thank you for supporting more than 1,000 of your peers with Merkel cell carcinoma to be able to get this information to help monitor the disease. The second area I want to turn to is therapy. How can we make treatments better? And to get at how to make treatments better, we have to understand why our treatments don't work when they don't work. So I'm going to talk about when immunotherapy stops working, why and how does the MCC escape? As you can imagine, this is a complex problem. Curing cancer isn't easy. Many cells are involved in any given tumor. Here I'm showing you a microcosm of a tumor where you can see the tumor cells in the grayish color, but also immune cells in blues and purples, including cancer-fighting T cells, and then also cells supporting the cancer, this fibroblast in green, or the blood vessels carrying red blood cells in red. When we go to look at this, it's a really complicated problem because all of the cells are all mixed together. So we get a tiny biopsy. We can't say, I want to look at just the cancer cells or just the immune cells or just the blood vessels, because if I try and sort them all out, I'll lose everything because I'm starting from such a small, tiny thing. Over the past 2 years, amazing new technologies have been developed, including technologies that have really been led coming out of Seattle, and then also collaborating institutions on the East Coast, including Dr. Satija's group, who is here today. And these technologies are based on an idea called single-cell RNA sequencing. What if I could look at every cell in a sample independently, all at the same time? And what if I could look at not just 100 cells, but 10,000 cells at once? When I started in Paul's lab, we used to get sequences, one sequence, 1,000 base pairs, 1,000. I get 250 million sequences, like once a week. So we're using these new single-cell RNA technologies, and this is how they work. First, we get the blood or the biopsy, as Max said, critically important. Thank you for getting us biopsy tissues. We know it's often annoying to have to wait for a biopsy or come back for a biopsy or participate in a biopsy, and we really appreciate your effort. We run it on this $150,000 toaster. The toaster puts a label on each and every cell. We then sequence every gene expressed in each of up to 10,000 cells at once. It's on this tiny little chip. As you can see, it's here next to a penny. This chip is actually outmoded. We just got a brand new sequencer called the NovaSeq that's blowing this one away, so I don't know what I'm going to do when I get over 1 billion sequences. But I know it's going to involve my friends who do advanced computing. So we collaborate closely with the Gotardo group, they're a biostatistical laboratory, along with the Belis group, who's a genomics laboratory, to be able to make sense of all of this data. When we get the data, we can't look at 250 million things at once. And so we look at these plots called t-SNEs. And the software to look at the t-SNEs is called Seurat. And much like the French painter, where you get all these individual dots, and you look at one dot and you say, I have no idea what's going on, you stand back and you can see the beautiful scene. You can see here that the boat is sailing by. Each cell on a t-SNE hangs out with its neighbors in space and is represented by a dot. And again, we look at one cell alone without the context of its neighbors, hard to make sense. But when we step back from the picture, we're able to see big trends. So how are we able to apply these technologies to Merkel cell cancer? We've learned that MCCs can hide from T cells in a very sophisticated way. So here I'm showing you the Merkel cell cancer as shown by the Hamburglar. And the cell you can think of as having 3 lights. These are the HLAs A, B, and C. They're what it uses to show its contents to the immune system, including the Merkel cell virus. And what the Merkel cancer does is it turns out just the light that is standing under. So when the immune system asks if the lights are on, it looks like some lights are on. It can't really tell that one light is out, but the immune system also can't see the Hamburglar standing there. Importantly, we know that which light the Merkel tumor turns off depends on which HLA type it has and where the virus is standing. So in different individuals, it can turn out different lights. And here I'm showing that to you on one of these t-SNE plots where the light is shown as blue. All the non-tumor cells are showing up as blue. And just in the tumor, the light has turned off. Now you can imagine if I had mixed everything together in a blender, everything would have looked light blue. So only by using these single cell technologies can we see that just the tumor has lost this exact piece critical to making it visible to the immune system. It would be very frustrating if I were standing here and all I could say was that we knew this light was going off. But we already know of some ways to get around this problem. One way is to target the immune system to another HLA, another light, and try and angle it so that the beam can see the virus. A second way is, what if we can just turn the lights back on? And in fact, we're learning that certain medications, including clinically available medications for other cancers, can turn these lights back on. And so we're very actively testing this preclinically with hope to bring it into the clinic soon. The third and final area that I'm going to talk about tonight, and I promise as we're 3 minutes past dessert time, I'll make it short, is can we teach the immune system to recognize Merkel cell cancer? So we know that for a third of patients, at least, who we give immune therapies to, that we don't see an initial shrinkage of their Merkel cancer in response to these PD-1 or PD-L1 drugs. And we think that a problem in at least a part of these patients, and also in a part of the patients whose cancers shrink and then come back, is that their T cells aren't very good at seeing Merkel cell cancer and seeing Merkel cell virus. So we've decided, what if you take those T cells that aren't very good at seeing Merkel cell cancer and Merkel cell virus, and you force them to see Merkel cell virus? Make better, stronger, more potent T cells and add them in along with these immune checkpoint inhibitor drugs to try and improve the efficacy of the immune checkpoint inhibitor drugs. So how does this work? This is work that's led out of Dr. Aude Chappuis's lab, where I'm currently at the Hutch, and it's work that depends on an extended research and clinical team. How it's going to work in practice is that we collect T cells from the peripheral blood. So this is a leukapheresis. Basically, we put an IV in the arm. It's a big IV in a big machine. It takes about 6-8 hours to collect the cells. Then in the dish, we're going to train the cells. We're going to engineer them to have a T cell receptor from a healthy person that's a very strong T cell receptor to see Merkel cell polyomavirus. So this treatment will necessarily, at first, be only for patients that have Merkel cell polyomavirus, and because it's experimental, very new cell engineering, will only be available to patients who need this extra level of treatment, so those that have been treated with a PD-1 drug or PD-L1 drug and their cancer has come back. These trained, focused T cells are going to be multiplied in the dish for just over a week. We're hoping for less than 2 weeks in total of cell processing time. And then we're going to infuse these T cells back to fight the cancer. Importantly, we know that T cells alone is not enough. So we have a complex protocol, the autologous transgenic T cell avelumab and class 1 MHC upregulation to fight advanced MCC clinical trial that we just call ATTACK. Because that's what we're trying to do. So there's some components of this. The first is we have a fire pit. We're targeting our T cells against the virus with hopes to focus them only on the Merkel cell carcinoma. Then as we build up our fire and burn up our cancer, we need to put some kindling on. When we infuse these really expensive, specialized, engineered cells, we want to give them the best possible shot at seeing, fighting, and destroying the Merkel cell cancer. So we're going to throw some kindling on in the sense that we're going to make that tumor visible to the T cells by using radiation to upregulate that HLA and turn the light on a little bit brighter when the T cells go in. Then we're going to throw on our match. These are our killer T cells, our CD8 T cells, and we'll fan the flames by giving them CD4 T cells to make cytokine support or chemicals to help the CD8 T cells grow and thrive. Finally, we know from patients that have responses to these immune checkpoint inhibitors that T cells in Merkel cell cancer can get tired. This PD-1, PD-L1 interaction can happen, and so we know from this experience, so we're going to keep throwing logs on the fire and use this avelumab drug to help hopefully prevent T cell exhaustion and sustain immune response. I'm very excited that this trial is going to be opening in 3 to 4 short months, assuming everything continues to go as well from a regulatory standpoint as it has. I hope that you'll consider participating in the trial and thank everyone who's considering participation in what will be a first-in-man early phase trial. And I hope to provide you more information as soon as I have it and as soon as we're enrolling. In summary today, you've heard about an incredible team of doctors, scientists, clinical support staff, patients, families, friends, donors, industry partners, academic partners, core facilities, university administrators, and many others who have come together to make incredible progress in Merkel cell cancer. You've learned about the progress that Dr. Niem and Dr. Bhatia have led that have changed the lives and the course of hundreds of individuals with metastatic MCC, and whose work has led to what will be soon multiple FDA-approved drugs for a cancer that just over a year ago had none. And finally, I hope that you hear that we're not stopping here, that even though we celebrate this wonderful success, we know we have further to go. And we hope that by learning about how to treat Merkel better, we will help more patients and also find things that will help other more common cancers. And with that, I'll turn it over to Paul, because it's almost dessert time.
Awesome. We're actually right on time. That's something we've never done before. We're 6 minutes early. So great time for dessert. And it's also time for our annual Team Merkel photo, because we have, like no other time in the year, a lot of people here in one place. That's a very special aspect of this. We don't get to see each other very often. I met multiple people on our team today for the first time. So folks in the other Brotman room, please come down here. We'll take a picture here in a few minutes, and then we'll join you for dessert. Thank you very much for coming.